Hello and welcome to this clip having a quick look at cis-trans versus EZ isomerism in alkenes. So first we need to introduce what stereoisomerism in alkenes actually means. So stereoisomerism in general is where two molecules have the same structural formula but the atoms are arranged differently in space. Due to restricted rotation of the carbon-carbon double bond in alkenes, they exhibit both cis-trans and EZ isomerism, both of which are a type of stereoisomerism. So for example, the carbon-carbon bond in alkanes can rotate freely, but in alkenes it can't. So we have what we call restricted rotation. So cis-trans isomerism is when two stereoisomers have two of the same atom or same group on two separate carbon atoms within the carbon-carbon double bond. So for example, if we take the CH3 as our exactly the same group, you can see that they are on the same side of the carbon-carbon double bond. So that would be the cis isomer. When they're on opposite sides, that's called the trans isomer. So looking at stereoisomers and structural isomers, if you take butene, for example, specifically, you can have but-1ene on the right-hand side, or you can have but-2ene, which is the left and middle. So the two versions of but-2ene are your cis and trans versions, and then but-1ene would be neither, so but-1ene counts as a structural isomer only. So sometimes this causes people to get a bit confused, so just to clarify, what you look out for is the same atom or group attached to the same carbon atom in the C-C double bond. So going back to our but-2ene, the cis and trans versions, let's have a look at how that applies when you use EZ isomerism. So for this you have to think about priority. So the same priority group are on the same side of the carbon-carbon double bond in the case of the Z isomer, and two of the same priority group are on opposite sides of the carbon-carbon double bond in the case of the E isomer. So let's quickly review assigning priority. If you look at the atomic number of the atoms, so look at the left-hand side of the carbon-carbon double bond in Z-but-2ene. So the carbon here is 6 as its atomic number, the hydrogen here is 1. So that means the carbon has higher priority and the hydrogen can have lower priority. So doing the same thing on the right-hand side of Z-but-2ene, you can see straight away that the high priority groups are on the same side of the carbon-carbon double bond. This is Z version, and the E version is when the high priority groups are on opposite sides, diagonally opposite. In other words, diagonally opposite like that. That's the E isomer. So the question is, do cis isomers always also end up being Z isomers and vice versa? So the answer in a nutshell is not necessarily. So if we do a quick look at this particular molecule and why it's a Z isomer, looking at the atomic numbers of the 4 atoms that are attached to the carbons in the carbon-carbon double bond, you can see that you've got the same priority on the same side. So that means it's a Z isomer. If you look at it from the cis-trans point of view, the same groups are diagonally opposite, so it's a trans isomer. And on the other one, the E2-bromo-but-2ene, the same groups are on the same side of the carbon-carbon double bond, so that would be a cis isomer. Okay, hopefully this has been a useful quick look at a comparison of these two isomerism types. Thanks for listening. Until next time, see you soon.